Hello, kids. How are you? I hope that you're doing good during these quarantine days, that you are sharing with your family and enjoying the company of your loved ones. Okay, remember that this is a week of a review. We are only going to make a review of most of the topics that we saw during the first term, and we are going to start today with the topic of powers, roots, and the logarithms. So let's start from the basics and let's remember, sorry, what a power is. Okay, as you can see here, a power can be understood as a repeated multiplication. For instance, if you want to do this operation and you see there an operation which is simple, 3 times 3 times 3 times 3 times 3. You repeat in a multiplication the 3 how many times? Well, you repeat it 5. So instead of writing that, because it's quite long, you can write 3 to the power of 5, as most of you should remember. And the result of that is 243. So let's check that a little bit with a little bit more of detail in the next slide. Okay, here you can see the 3 is the number that you repeat, and that becomes what we call the base in a power. It's the number that it's written in a normal size, and the amount of times that you repeat it in a multiplication, which in this case is 5, becomes the exponent. And remember, the exponent, you write it a little bit smaller, not over the normal line. It's a little bit up, and it's next to the base, like you can see in the slide. So 3 to the power 5 equals 243, because if you multiply 3 times 3, it is 9. If you multiply times 3 again, it will be 27. And if you do it again, it will be 81. And one more time, it's going to be 243. So that relates directly to one mistake that I want you to avoid from now on, because I know that some of you still do it like this, because maybe you don't pay a lot of attention to, um, or you don't remember exactly how exponents work, how powers work. So let's look at the next slide. Okay, never make this mistake again, please. Because some of you make 3 to the power 5 equals 15, because you think that 3 to the power 5 works the same as a multiplication, and you know that 3 times 5 is 15. But I have told you many times that it's not like that. 3 times 5 is 15, but if you multiply 3 times 3 times 3 times 3 times 3 5 times, it's going to be 243. So the results are different, so they are not the same operation. So please try to avoid that mistake. Please remember always that multiplying is not the same than making a power. And okay, let's move on to the roots. Not square roots, because square roots are only one type of roots. You have many kinds of roots. So let's check. Okay, and roots are one of the inverse operations to powers. The other inverse operation to power is logarithms, but we are going to talk about logarithms in a little bit more. So roots are one inverse operation to powers, and what happens that you can make a root, you have to make a root if you know the base, sorry, if you know the exponent and the result of a power, but you don't know the base. So how do you find a base? You make a root. Like in this example. Here you can see that the little 5, which is over the root sign, is what in a power normally is in the place of the exponent. And the 243, which is inside of that box of the root sign, is what normally is in the result of the power. So what is missing? The base, which comes in as the result of the root. But maybe to some of you that results that is a little bit confusing, so you can think about roots in a different way, and maybe that helps you understanding this a little bit more or a little bit easier. So you can think about roots like this. Imagine this example, cubic root of 64, or you can also say it third root of 64. The result is a number, and we don't know that number yet, so we are going to name that number with the letter n. So the result of that is a number that multiplied by itself 3 times is 64. Let me remind you, multiplied by itself in Spanish means multiplicado por sí mismo. So this is a number that you multiply times that same number. How many times? 3, because the little 3 over the root sign tells you that amount. It's 3. So imagine n times n times n is 64. Remember, n is the name that we give it to that number because we don't know it yet. And with a little bit of trial and error, you can see that 64 is equal to 4 times 4 times 4. So you repeat the 4 3 times in that multiplication to get 64. That means that 4 is the result of that root. Now, let's switch to logarithms, which is a little bit similar, but in that case, you know the base. What you don't actually know is the exponent of a power. So logarithms are the order inverse operation to powers, and they happen when you know the base and the result, but you don't know the exponent. So here in the bottom part of this slide, you can see an example of a logarithm, what those numbers used to be in a power. So the little tree that is always next to the g, in that case, was the base of a power, and the 243 was the result. What didn't we know? We didn't know the exponent. But if you do a logarithm, you're gonna get the 5, the exponent, as a result. But I know that that may be a little bit confusing for some of you. So you can think about the logarithms in a different way. It may be it's easier for you. Okay, let's look at this example. Logarithm in base 4 of 64. The result of that is a number of times that you multiply 4 by itself to get 64. So you know the base, and the base is 4. You repeat the 4 sometimes, a certain amount of times, and you get 64. So you can do it. Okay, let's start with 1. 4 times nothing, 4 times 1, actually, it is 4. We don't get 64. Another time, 4 times 4. That's 16. We didn't get 64. One more time, 16 times 4. 16 times 4 is 64. Okay, we got the 64. How many times did we multiply the 4? We multiplied it 3 times. So the result of the logarithm is 3. And that's it. Okay, so now I want you to try to apply those concepts in some exercises that we have already done during class. So if you have your notebooks, please take it. And in one column, the first column, you have to convert to a root form. So you have powers and logarithms. You have to transform those expressions to their equivalent expression in a root form. And the same for the other column. In the right column, you have to convert to logarithm expressions. Okay, so I want you to pause the video a little bit and try to make these conversions on your own. It should not take too long, but as you know, you can pause whenever you feel comfortable with the results that you have, because we are going to discuss the results, the answers, later. Okay, so now we came back, and here you see the answers for those exercises. I am going to discuss some of them. so you can understand why they are like that. So remember, when you have a root, the result is the base. So if in the first exercise the base was 2, the base had to be in the result. And if in that same exercise the exponent was 5, the 5 has to go over the sign of the root. And the number that is left, which is 32, goes inside the box. Quite simple. The next exercise, logarithm in base 10 of 100 equals 2. Okay, remember, if in roots the result is the base, here we see the base, which is 10. That has to be in the result. The exponent is 2. Remember, the logarithms give the exponent in the result. So the 2 goes upside the sign of the root, and the number that is left, which is 100, goes inside the box. And the other exercises are done in the same way. 7 to the power 2 equals 49, converts to square root of 49 equals 7. And logarithm in base 6 of 216 equals 3, converts to cubic root of 216 equals 6. Now let's check the second column. And the first exercise of that column is square root of 81 equals 9. So you transform it to logarithm in base 9 of 81 equals 2. Because remember, in a root, the result is the base. So the base has to be next to the g in a logarithm. So the 9 goes there. The exponent in a root, which is 2 in this case, goes in the result in a logarithm. So you put the 2 in the result, and the number that is left is the 81. So it goes after the 9 and before of the equal sign. And the next exercise, 3 to the power 2, or 3 squared, equals 9. So if the base is 3, in the logarithm, the 3 has to go next to the g. And if the exponent is 2 in this case, the exponent in a logarithm goes after the equal sign, is the result. And what number is left? We are left with the 9, so that goes between the 3 and the equal sign. And the other two exercises are done in the same way. Fifth root of 1024 equals 4, transformed to logarithm in base 4 of 1024 equals 5, and 22 to the power 3 equals 10,648, transforms to logarithm in base 22 of 10,648 equals 3. Okay, now I want you to try to apply those concepts now, not to exercises, but to some word problems. So let me read it with you, and I want you to pause after I finish reading to try to solve it on your own. And don't worry, because after you play this video again, we are going to discuss the answers. You are enlarging a photo on your computer screen. Enlarge means to make it wider, make it longer, make it larger, or in Spanish, alargar o ampliar. So you're enlarging a photo on your computer screen. The photo starts at 3 centimeters wide. Each time that you enlarge the photo, its width is doubled. So it means that you are multiplying it times 2. But how many times? You enlarge the photo 4 times. What is the final width of the photo of your screen? So pause the video and try to solve it on your own. Okay, we are back. So here in the first line, you can actually see that you can solve the problem without making any power, root, or logarithm, but we can also write it using that. So 3, the number 3 is the original amount, the original width of the photo. So it was 3 centimeters. And you double it. So that means multiplied by 2. But as you double it 4 times, you have to multiply times 2 4 times. So it's 3 times 2 times 2 times 2 times 2, which actually results in 48. The result of the problem, the answer, is 48 centimeters wide. But wait, because we didn't use any exponent. But we can do it, because remember, exponents are repeated multiplication. So you can see that there are a lot of 2's in a multiplication. You're repeating the 2's. So we can simplify that and we can write it as exponents. As you can see in the third line, we convert all of those 2 in multiplications into 2 to the power 4 because you repeat it 4 times. And 2 to the power 4 is 16, as you can see following the paths of the arrow. And if you multiply 16 times 3, you get 48. So you can do it also using exponents. And that will result really useful when we start seeing and trying to solve more complex problems in next terms. Now, another problem. This is a problem that is really, really similar to what we saw during 3 or 4 classes, if I'm not wrong, during this term about the cells problem. Okay, so if you have your notebook next to you, please open it and try to look at the problems of the cells, and after that you can try to solve it. Okay, a single cell started dividing 5 days ago. Every cell divides into the same amount each day. Now, there are 16,807 cells. How many cells were there at the beginning? So try to solve it, and we are going to get back in some moments. Okay, you may remember this. This is chart that we use to organize the information in problems that related to exponential growth. So you may remember that in problems like this, we treated the days, the number of days, as an exponent. So we start always in day 0 because there was when it all started and there was only one cell. And next, you have day 1, day 2, day 3, day 4, day 5. But wait, we didn't know how many cells were at the beginning after they divided the first time. But you know that in day 5, there were 16,807 cells. So, what do you know? You know the exponent and you know the result of the power. What you don't know is the base. So remember from some slides ago, if you don't know the base, you should make a root. And here, you see all of the results. In the day 1, we had 7. But how did we find it? Well, we made the root. Fifth root of 16,807 is 7. Now, let's move to another problem. And this problem is really easy because right away you can understand that you want to find the exponent. What is the exponent of an expression if the base is 65 and the result is, wow, that's a big number, 17,850,625. Well, you want the exponent. And if you have been paying attention to this presentation, you only have to make a logarithm. Logarithm in base 65 of 17,850,625 equals 4. How do you have to do it? Well, remember that we tend to use calculator, or you can also make a similar chart to the previous problem. But if you don't remember exactly how to make logarithms, roots, or powers in a calculator, a scientific calculator, I also created a little video of me explaining you how to do it. That video is really short. It's not more, sorry, than 4 minutes. And you can find the link for that video in the Padlet. So thank you very much. This is the end of this presentation. And after this, I want you to practice a little bit with an activity in the platform Alex that should be already activated for you. If you have any question, remember that I am always answering through videos, and see you next time.